Okay, so we're starting from question number 8. Although it was the homework question, but somebody requested me to make a video for that. So we're doing that. Okay, with respect to origin O, the position vectors of A and B are this and this. The point P lies on the line through A and B, and AP is equals to lambda times AB. So there's a vector. No, yes. P lies on the line through A and B. Okay, so there's a point A, three-dimensional point, another three-dimensional point B, and a line passes through it, and they're saying that P lies on this line. So it can be anywhere on the line. So let's say P is here, and there's a ratio given that AP is equals to lambda times AB. Okay. Show that OP equals that. Okay. Now, how do we show OP? You have to start with this ratio. AP is OP minus OA lambda times AB is OB minus OA. Now let's substitute the values. OP is what we have to find, and I'm going to send OA to the other side. So we have lambda OB minus OA. So OB is 340 minus OA is 122 and plus OA. So it's going to be plus 122. Okay, so we have OP equals lambda times, subtract this, we get 2, and we get minus 2. So that's 2, 2 and minus 2. And we have plus 122. So we have OP equals 122 plus lambda times 2, 2 minus 2. Combine this, we get OP equals 1 plus 2 lambda, 2 plus 2 lambda, and 2 minus 2 lambda. And in terms of IJK, this is going to be OP equals 1 plus 2 lambda I plus 2 plus 2 lambda J plus 2 minus 2 lambda K. So we've done the first part. If you have any questions regarding this, please ask. Part 2. By equating the expressions for cos AOP and cos BOP in terms of lambda, find the value of lambda for which OB bisects angle AOP. Okay, so basically all you have to do is equate these two. So let's do that. I'm going to clear the board. So they're saying equate cos AOP and cos BOP. So we take cos theta when we're trying to find angle between two vectors. So the first one is AOP. So I'm going to draw it AOP, and the other one is BOP. And this is the angle and this is the angle. So we're going to draw the lines outwards. So cos AOB is going to be OA dot OP upon magnitude of OA times magnitude of OP equals to OB dot OP upon magnitude of OB times magnitude of OP. Okay, in the numerator, we have to take dot product, but in the denominator, you can cancel the magnitude of OP on both the sides. Now let's work out the numerators. We have OA, which is 122, dot OP. OP is 1 plus 2 lambda, 2 plus 2 lambda, and 2 minus 2 lambda. Upon OA, which is square root of 1 square plus 2 square plus 2 square, equals to OB, which is 340, and OP again, which is 1 plus 2 lambda, 2 plus 2 lambda, and 2 minus 2 lambda. And denominator will be the magnitude of OB, which is 3 square plus 4 square plus 0 square. Okay. So dot product of the left hand side, that's going to be 1 plus 2 lambda plus 4 plus 4 lambda plus 4 minus 4 lambda divided by what is denominator is 9. So square root of 9 is 3. We get 3 here, equals to, before I manipulate the right hand side, this and this is getting cancelled. And I have 2 lambda plus 9 upon 3 equals, what chances है कोई calculation में mistake होने के. So please keep an eye on my working. 3 plus 6 lambda, 8 plus 8 lambda, and 0, 0, the last term is just going to be 0. Okay, upon, that is going to be 5 square root, yes, that's the denominator is going to be 5. Okay, so we have 14 lambda plus 11 over 5. यहाँ पर मुझे चेक करना है तो सही है कि गलत. I think सही है. चलते हैं आगे. Okay, cross multiply 10 lambda plus 45 equals 14 times 3 is 42 lambda plus 33. So we have 32 lambda here and 12 here, and lambda will be 12 divided by 32, which is 3 by 8. Yes, that is correct. Find the value of lambda for which OB bisects angle AOB, so done. You don't have to worry about this part where OP bisects the angle AOB. That means the thetas should be equal. And if the thetas are equal, then their cos AOP and cos BOP are also equal. So they just gave that relationship to you in the start. अगर ये ना बताया होता तो फिर आपको इस पे सोचना पड़ता कि अच्छा, if that line is bisecting the angles, that means these two angles are equal. That means their cos theta is also equal. So no need to worry about that here. Okay. When lambda has this value, verify that AP dot APB equals OA dot OB. AP dot PB dot carry AP ratio PB is equals to OA ratio OB. Okay, so we have the expression for AP and PB. not really, but बना सकते हैं. Let's lambda की value हमें पता है 3/8. So remember the equation I made in the start, the figure I made in the start. I'm going to redraw that. It says AP is equals to lambda times AP. So I said that there's a vector and there's A and B on it somewhere. And there's P on it somewhere. And you know that AP upon AB is equals to lambda, right? From here, AP upon AB will be lambda. So lambda is 3/8. So that means AP has 3 parts. Then AB has 8 parts, which means PB has 5 parts. So we have this ratio. AP ratio PB is 3:5. So AP ratio PB will be 3:5. You could have used a very longer method to find this AP ratio PB. आप पहले lambda की value OP के expression में substitute करते इधर उससे OP आ जाता OP आता तो AP भी आ जाता because we already know A, and then PB भी आ जाता because we already know P, and then you would have 2 column vectors on both sides, and then you would have taken their magnitude. And when you had entered that in the calculator or simplified the ratio, you would get 3:5. But that is a long method. So instead, what we did is we used this ratio to figure out what is AP ratio PP. अच्छा, ये तो हमें पता चल गया, that's 3:5. Now we have to show that OA ratio OB is also 3:5. So for ratios, you can find the magnitudes of the column vectors. So OA is 1, 2, 2. Ratio OB is 3, 4, 0. So I'm going to take the magnitudes. 1 square plus 2 square plus 2 square ratio square root 3 square plus 4 square. So the right hand side is 5 and the left hand side will be square root of 9, which is 3. So hence AP ratio PB equals OA ratio OB. That was all of question 8. Now we start 9. With respect to region O, the points A and B and C have position vectors this, and this. Find the length of the perpendicular from C to the line passing through AB. Okay. So we have a vector again. And A and B are 2 points on this vector. And then there's another point C somewhere, and you have to find this perpendicular distance. Okay. How do we do that? First, we need the line passing through A and B. So for that, I'm going to use R is equals to A plus lambda P minus A. When we have 2 coordinates on the same vector line, we use this formula. So R equals A is 3 minus 2, 4 plus lambda B minus A, which is going to be 2 minus 1, 7 minus 3 minus 2, 4. So we have R is equals to 3 minus 2, 4 plus lambda. We have minus 1, we have 1, and we have 3. All right, that's R. The vector equation passing through A and B. Okay, now I'm calling this point here X. Since X lies on the same vector, so OX is going to have the same coordinates as the number line. 3 minus lambda, minus 2 plus lambda, and 4 plus 3 lambda. I've merged the two independent column vectors. So let me just double check. Okay. So we know OX now. So from here we can find CX. CX is OX minus OC. So that is 3 minus lambda minus 2 plus lambda and 4 plus 3 lambda minus OC, which is 1 minus 5 minus 3. So we have CX equals 2 minus lambda, 3 plus lambda, and 1 plus 3 lambda. Let me confirm. Seven. Should be 7. Yes, it will be 7. So yeah, found a mistake. 7 plus 3 lambda. Okay, so that's CX. Now we have the column vector CX, and we know CX is going to be perpendicular to this direction vector. CX, the yellow line, is perpendicular to the green line, we know that, but it is also going to be perpendicular to the direction vector of the green line, because direction vector is a vector that is parallel to the green line. So these two lines will have a perpendicular angle between 90 degrees angle between them as well. So I'm going to take dot product of CX and minus 113. So Cx is 2 minus lambda, 3 plus lambda, and 7 plus 3 lambda. And take dot product with minus 1, 1, 3. And equate it to 0. And we should equate this to 0. And the answer should come out to be minus 2. Let's see if we get that or not. Lambda should come out to be minus 2. I'm just writing it here. So let's see, minus 2 plus lambda, then 3 plus lambda, and then 21 plus 9 lambda equals to 0. 9, 10, 11. So we have 11 lambda here, and we have minus 22 here. So yes, we do get lambda is equals to minus 2. Okay. Once we have lambda, we're going to substitute that in Cx and then take its magnitude to find the perpendicular distance. So Cx is going to be 4, 1, and 1. So magnitude of Cx is 4 square plus 1 square plus 1 square, which is square root of 80. Do we have specific requirement? Find the length of the perpendicular. Okay. So you may leave it as surd, which is 3 under root 2. The simplified surd is 3 under root 2. I just entered under root 18 in the calculator and it simplified it for me. Or you can give answer in 3 significant figures, 4.24. Usually in the question, one of these is specified. Either it will say give your answer in exact form, then this is your final correct answer, this one. And if it says give your answer correct to 3 significant figure, then this is your final correct answer. Okay, that was question 8. If you have any question, please ask in fact question 9. I think this is going to be the last day we spent on this topic, inshallah. On Monday, we will start partial fractions, very easy topic. Then binomial theorem, another very easy topic. उसके बाद complex number, differentiation, integration, and differential equation. अभी तो बहुत रहता है. But inshallah, we'll be done by August and half of September, maximum end of September. P3 will be done within this time. Hopefully mid of September. Question 10. Two lines have equation this and this, where P is a constant. P किधर है? Okay, right here. Where P is a constant. It is given that the lines intersect. If the lines intersect, that means we should be able to equate them. Okay, find the value of P and determine the coordinates of point of intersection. Okay, so if they are intersecting, I'm going to equate the two 5 plus S 1. Let me clearly distinguish between 5 and S. S would be like this. Okay. And then 1 minus S, and then minus 4 plus 3S. Equals to P plus 2T, and then 4 plus 5T, and then minus 2 minus 4T. Okay. Now the first equation has P, so it has 3 unknown variables, S and P and T. So I'm not going to touch the first equation for now. I'm going to solve this equation, this set of linear equation, and this one, and get S and T from these two, and then substitute S and T in the very first equation, and then find the value of. Okay, so I'm getting 1 minus S is equals to 4 plus 5T. So minus S is equals to 3 plus 5T, and then S is equals to minus 3 minus 5. Okay. Substitute it in the second equation, minus 4 plus 3 times minus 3 minus 5T equals minus 2 minus 4T. So minus 4 minus 9 minus 15T equals minus 2 minus 4T. So we have minus 11 is equals to 11T. And then T is equals to minus 1. Let me go. And then find S. S is minus 3 minus 5T. Minus 3 plus 5, which is 2. That is correct. Okay. Now, once we have T and S, what we're going to do is substitute it in the very first equation and get the value of P from there. So we have 5 plus S equals P plus 2 times T, which is 2 times minus 1, which is minus 2. So we have 5, 6, 7, 8, 9. P equals 9. Yes, that is correct. Find the value of P and determine the coordinates of point of intersection. So for coordinates of point of intersection, all that's left to do is substitute S, P, and T in the first step. The meeting will end in 10 minutes. Heather, please remember to send a new link. Okay. 5 plus S is going to be 5 plus 2, which is 7. 1 minus S is going to be 1 minus 2, which is minus 1. And minus 4 plus 3 times S. Minus 4 plus 3 times 2 is 2. Okay, that is going to be the point of intersection. But just to confirm that I haven't made any algebraic mistake, I'm going to also substitute it here. And I should get right hand side is equals to left hand side. P plus 2T. P के आया था 9. 9 minus 2 is 7. 4 minus 5 is minus 1. Minus 2 plus 4 is going to be 2. So yes. Find the coordinates of points of intersection. So that's going to be 7, comma, minus 1, comma, 2. If the question had asked for position vector of point of intersection, position vector, then your answer would have been 7i minus j plus 2k. Or since this question is not in IJK format, in the marking scheme, they would also accept 7 minus 1, 2. Question 11. Anybody has questions, please ask. Point P has coordinates minus 1, comma 4, comma 11, and line L has equation R is equals to this. Find the perpendicular distance from P to line L. We've literally done this tens of times. I hope by now you remember the method. Because the only tricky part is remembering the steps. So the vector equation is R equals 1, 3 minus 4 plus lambda 2, 1, 3. There's a point P with coordinates minus 1, 4, 11. And you have to find this perpendicular distance. Now, first of all, we're going to find position vector of a point X here. And we know that since X lies on the red vector, it will have the same position vector. 1 plus 2 lambda, 3 plus lambda, minus 4 plus 3 lambda. 1 plus 2 lambda, 3 plus lambda, minus 4 plus 3 lambda. Okay. And now I'm going to find Px as well because I need to take the dot product of Px and the red line and equate that to 0 since these are perpendicular vectors. Okay, so Px is going to be Ox minus Op. So it's going to be 1 plus 2 lambda, 3 plus lambda, and minus 4 plus 3 lambda. Minus 1, 4, 11. So it's going to be 2 plus 2 lambda, minus 1 plus lambda, minus 15 plus 3 lambda. So let me take it again. That is correct. Now we're going to take dot product of Px, this was Px, and the red line. But we're not going to take the dot product with the entire red line because it also has lambda in it. And we don't want to complicate things. And we know that this line this direction vector is a vector parallel to the original vector. So the dot product between the green line and the blue vector is also 0. So we're going to find the dot product between these two. So we have px dot direction vector 2, 1, 3, and this is equals to 0. 2 plus 2 lambda minus 1 plus lambda and minus 15 plus 3 lambda dot 213 equals 0. So it's going to be, so मैंने zoom out किया हुआ 4 plus 4 lambda, then minus 1 plus lambda, and then minus 45 plus 9 lambda equated to 0. So we have 14 lambda here, and at the other side we have 46 minus 4, which is 42. I hope they divide completely. This is 42. Yes, I think 3 se divide hota hai. Lambda is equals to 3. Let me confirm that. Yes, lambda is equals to 3 is correct. Now all that's left to do is find the green vector px and then find its magnitude. So we already have px in terms of lambda. From here, we'll find the actual column vector px, and then in the last step, we will take its magnitude. So px is going to be 8, 2, and minus 6. And then take its magnitude. Magnitude of px is 8 square plus 2 square plus 6 square. Which is in third form. If the question had said give the exact answer, this would have been an exact answer. Since the question is not specific, we could give the exact answer or 3 significant answer, which is 10.2. Answer in the marking scheme is 10. Okay. If you've copied this, please leave the class and then I'll end the lesson and Heather will send us a certificate. Lines L and M have equations R equals to this. Okay, so we have two vector equations L and M respectively, where A and B are constants. So there are more unknowns here apart from lambda and mu. There's an A here and there's a B. Given that L and M intersect, if the two lines intersect, that means we can start solving them simultaneously. Show that 2A minus B is equals to 4. Okay. So let's solve them simultaneously. 3 minus 2, 1 plus lambda. In fact, let me just merge these into one column vector. So 3 minus 2, 1 minus lambda plus 2 lambda and plus lambda equals to 442 plus mu A plus mu B minus mu. Well, let me just confirm. 3 minus lambda is equals to 4 plus mu A. Minus 2 plus 2 lambda equals to 4 plus mu B. And 1 plus lambda equals to 2, okay, minus mu. Okay. So now what we'll do, we'll solve them simultaneously and we should be able to get this. Okay. So what I'll do, I'll first write mu in terms of lambda or lambda in terms of mu using these. So from here I know that lambda equals to 1 minus mu. Lambda is equals to 1 minus. Okay. Now I'm going to substitute this both in the first equation and the second equation. Okay, so we have 3 minus, instead of lambda, I'm writing 1 minus mu. My screen has started to lag slightly, is equals to 4 plus mu A. Okay. So 3 minus 1 is 2 plus mu equals 4 plus mu A. Okay. So I have now 2 on the left hand side. At the right hand side, I'm going to move both my mu terms and I'll get 1 minus A here inside the bracket. I've skipped a step and now I can make mu the subject. So in the first equation, I've managed to make mu the subject. So mu is equals to 2 over 1 minus A. I'll do the same with the second equation, and in the second equation I'll also make mu the subject and I'll get something in terms of B, and then I'll equate the two mu's in both the equations and I should be able to get that equation 2A minus B is equals to. I hope there's no mistake so far. कोई भी तो थोड़ी देर में पता चल जाएगा. Okay. Now I'm going to use the second equation. And here also, instead of mu, instead of lambda, I'm going to substitute 1 minus mu. Okay, so we have minus 2 plus 2 times lambda is 1 minus mu equals 4 plus mu times b. So we have minus 2 plus 2, which is 0, then minus 2 mu excuse me, is equals to 4 plus mu times b. Okay. So I'm going to write minus 4 here. At the right hand side, I'm going to move both the mu terms and I get b plus 2. That gives me mu equals minus 4 over b plus 2. Equate both the mu's and hopefully get that required. Equate this with this. So we get 2 upon 1 minus a equals minus 4 over b plus 2. I'm going to cancel this and this, and cross multiply. So we have B plus 2 equals minus 2 plus 2A. So I'm getting 2A minus B is equals to 4. Thank God. So we got the required equation. Two A minus B is equals to 4. That is how we were to do part 2. Any questions here? Part D says that given that vectors L and M are perpendicular, find the values of A and B. Okay. If the vectors are perpendicular, that means their dot product is going to be 0. But we're not going to find the dot product of the entire vectors. We're going to use slightly less time consuming approach. We will take the dot product of their direction vectors instead. Because as we've discussed many times before, that the direction vectors are parallel to the original vectors. So if two vectors are perpendicular to each other, then their direction vectors are also perpendicular to each other. So direction vector of line L is this, -1, 2, 1. And direction vector of the vector M is A minus 1. Their dot product will also be 0. -1, 2, 1 dot A B minus 1 equals 0. So minus A plus 2B minus 1 equals 0. So I have minus A plus 2B equals to 1. Now what you guys will do is you will solve this equation and this earlier equation in terms of A and B. Solve these two simultaneously and tell me what value do we get for A and B. करके बताओ. Equation 1. This is equation 2. Solve these simultaneously. ये कोई कर रहा है solve या नहीं कर रहा? मैं ही बता दूं. When you solve these, your answers should be A equals 3 and B equals 2. Okay. When A and B have these values, now we're doing part 3. When A and B have these values, find the position vector of point of intersection of L and M. Okay. So now all that's left to do is we had already equated these in the very first part of the question. So in that you substitute the value of lambda, the value of mu, and A and B as well. And you should get the point of intersection on both sides. We don't need to waste that much time. I will just use this. R equals to the first one. क्योंकि उसमें मुझे बस लेमडा सब्स्टिट्यूट करने की जरूरत है. राइट वाले में मुझे ए बी और म्यू भी सब्स्टिट्यूट करने की जरूरत है. नहीं अभी नहीं, खाने के बाद. Okay, so we get 3 minus 2 1 from earlier plus lambda -1, 2, 1. In here, just substitute the lambda we got earlier, which was did we find a lambda earlier? I don't think so. Karna padega. We will have to find the lambda. Yes, we don't have lambda earlier. Okay, so that's a little more effort. Okay. So equate it to the other equation, which is 442 plus mu times A, B, and minus K. A is 3, B is 2, and minus K is just minus. Okay. Now solve these, get the values of mu and lambda, substitute them back in any one of the sides, and get the point of intersection. So we have 3 minus lambda equals 4 plus 3 mu. Equation 1. Let me just slightly simplify this as well. 3 I can write minus lambda equals 1 plus 3 mu, and lambda is equals to -1 minus 3. Okay. Now take the second equation. -2 plus 2 lambda is equals to 4 plus 2 mu. You may substitute this here and you will solve this yourself and get the value of mu or lambda. Lambda should come out to be 2 after solving these simultaneously. And mu should come out to be -1. Now you put them back and you'll see you'll get 3 similar coordinates on both the sides. Very correct then. Lambda is 2. So we get, when lambda is 2, we get 3 minus 2, which is 1. Then -2 plus 4, which is 2. And then 1 plus 2, which is 3. And then when mu is -1, this should give us the same coordinates. Equals to 1, 2, and 3. Yes. So the points of intersections are 1, 2, and 3, which is the correct answer. What is the final requirement? Position vector or just the coordinates? Position vectors. And the question is in IJK format. Your final answer must be in IJK format. So position vector is I plus 2J plus 3K. All right, that's all for today, and that's all from the topic of vectors. There are a few questions left, but they're all the same. Either find the perpendicular distance or find the points of intersections of two vector. वही चीजें हैं जो हम काफी दफा कर चुके हैं. So we're not going to do any more of that. It'll be very good if you do it on your own. And if you have any questions, you can text me and we can go over it in class. Otherwise, that's all from my end from vectors. Or inshallah, from Monday we'll start the next chapter. Next 2 chapters काफी छोटे हैं तो inshallah relatively जल्दी होते हैं. All right. Take care. I'll see you on Monday now. Have a great weekend. Allah Hafiz.
Allah Hafiz, ma'am.